Okay, we had in our vocab geometric sequences, and I referenced arithmetic sequences in defining the geometric sequence. So let's just identify both. In example 1, is the sequence an arithmetic or a geometric sequence? So what we need to do to answer this question is we need to look for either a common difference, that would be for arithmetic, or a common ratio for it to be geometric. I do think that sometimes the common difference is the quicker one to figure out if you have that. So the common difference, how we find that, is we take a look at our sequence. We're going to take the second term and subtract the previous term from that. So we're going to take 2 minus 3, and we got a negative 1. Now let's do that again with the next set. So we're going to move to the third term, and we're going to subtract the previous term from that. So 4/3 minus 2. When you guys are checking these and you want to be quick about it, feel free to use that calculator button on, or fraction button on your calculator to make this quick for you. 4/3 minus 2 is a negative 2/3. So what we're finding is a difference of negative 1 and a difference of negative 2/3. That's not common. It's not the same number. So we know that the sequence is not arithmetic because there was not a common difference. Well, let's check to see if there's a common ratio. And I'm kind of tight on space. Hopefully you guys are writing smaller than me. So to find the common ratio, if there is one, same idea, you take the second term and we divide it by the previous term. So 2 divided by 3. Now let's take the third term, 4/3, and divide it by the previous term to that. Now 4/3 divided by 2 is a 2/3, and we do have to check through the whole sequence. So far we have a common ratio of 2/3. So do we get a 2/3 every time? So next we would check 8/9 divided by 4/3. That is also a 2/3. And then we would check 16/27 divided by 8/9. And that is 2/3. So because we got a 2/3 ratio on all of these, that makes this a geometric sequence. Okay, I am going to move this down here. And I'm just going to kind of ignore it for a second. So we have a geometric sequence with our common ratio equal to 2/3. All right, so let's move on to capital B. Is it arithmetic or geometric? Look for a common difference or a common ratio. So again, the difference might be the faster one to look for. We're just subtracting 4.5 minus 3, we get 1.5. Then take the third term, 6 minus 4.5, that's another 1.5. 7.5 minus 6, 9 minus 7.5. Because that number is the same, that means that there is a common difference. So this sequence is arithmetic. And a common difference of 1.5. So you might feel like, well, I got a couple common differences. Do I really need to go through all of them? You do. They're going to try to throw one at you that throws off the common difference, and you would say, oh, it's not arithmetic. Let's say this 9 was a 10 instead. You would have found 1.5, 1.5, 1.5, and then a difference of 2.5. Then you would say, oh, the sequence is not arithmetic because it didn't have a common difference through the whole thing. So it might feel like kind of a pain, but we do have to check the whole sequence. All right, moving on to lowercase a. Let's look for a common difference first. What is nice about this, if we do 2.2 minus 1, we get 1.2. Then let's do 4.84 minus 2.2, and we get 2.64. So right now, those are not the same. So there is not a common difference. It's not arithmetic. So let's check to see if it's geometric. Let's look for a common ratio. So second term, 2.2 divided by the first term is 2.2. Let's see, third term, oops. .84 divided by 2.2 is another 2.2. Then we have 10.648 divided by 4.84. All we're doing is we're taking the term and dividing it by the term before it. That's another 2.2. And then 23.4256 divided by 10.648, and that is another 2.2. So because we had a common ratio that makes the sequence geometric, and the common ratio is that 2.2 that we found. Okay, last example. Let's hope it's arithmetic, right? That's just the fast one to find. All right, let's see if we have a common difference. Take the second term minus the previous term, we get 74. Take the third term of 149 minus the second term, 75. Oh, that's 74. Then we'll take 223 minus 149, another 74. And 297 minus 223 is 74. So this sequence is arithmetic with a common difference equal to 74.